Welcome to Chemistry in the Car with Sam. So you missed a few problems with Josie and I at the end of class, so I thought I'd help you along with them. So let's get going. So your first problem is finding the mass percentage of the water in our hydrated salt. So you're going to take these two numbers, 0.058, the mass of the water that we found, and the mass of the total hydrated salt, 0.113, you're going to divide them. So 0.058 divided by 0.113. And after you deal with all your sig figs, that brings you out to a nice round number of 51%. Just over half of the mass of the hydrated salt. Moving on. So you have the molar mass of water, 18.02, and you have the mass in your table of the water that we evaporated, 0.058 grams. So you're going to take that 0.058 grams and you're going to divide it by 18.02, which should bring you out to your answer of 0.0032 moles of water that were in our hydrated salt. So your final question for this lab, before you get to the conclusion, is how many moles of unhydrated salt did we have in the end? And it's the same question as the water question. You've got to find the molar mass of the salt, which he gave to us as 158.52 grams per mole, which is strontium chloride, SrCl2's molar mass. And you need to know the mass of the salt that we had, which was 0.055 grams. Now, you got to do the same thing. Take the grams of salt that we had and divide it by the 158.52 grams per mole molar mass of that salt. And that comes out to be, after you deal with sig figs, 0.00035 moles of salt that we used. So there's your work and your answer for the final problem. Now for the first problem of this conclusion, I cannot do it while I'm driving, so I'm just going to hold it here and explain it to you. So what you got to do is you need to figure out the lowest whole number ratio of moles of salt to water. So you know that we need 1 mole of salt compared to some number of moles of water. So to start out, you find what you need to multiply the number of moles of salt by to get it to 1. So you do 1 divided by 0.00035 moles, which is what we determined in the last question, which comes out to be 2,857-ish. With sig figs, it's 2,900. Now, you're going to multiply 2,900 times the number of moles of water that we had, so that they've been multiplied by the same number, because we can't multiply one by 5 and the other by 2. So that will give us the number of moles of water for every 1 mole of salt. So it's going to give us 9.28 moles of water for every 1 mole of salt. However, it has to be the lowest whole number ratio. So 9.28 doesn't work, so we've got to round it down to 9 moles of water for every 1 mole of hydrated strontium chloride. So the final answer will be written in this format: SrCl2, strontium chloride, little multiplication dot, 9 moles of H2O. Alright, now the second conclusion question is pretty simple once you think about it for a little bit. It did take me a little while to figure out, but it's very, very intuitive. So, what happens when stuff cools down is really what it's testing your knowledge of. Well, particle speed within that substance slows down and things condense, right? So when things condense, they all go back into one shape, right? They go back into their original form. So if there was any water vapor that was kind of on the edge of evaporating and was still stuck in the crucible, that cooling down gives that water time to condense and get back into the salt, so that then we can get a true reading of how much water is still left, because we haven't fully evaporated it yet. So we got to give it time to cool down so that it can all get back inside of the salt. And so that's why cooling is necessary when massing these, or else we will think that we have lost more than we actually have. Now the next problem, I think you are very much smart enough to figure out, but you've had a long day, so I'm going to help you along with it. So why must you get 2 successive mass readings? That's because if you don't, then like he was saying, if you only take 1 reading and you assume that that is good, then you might not have gotten everything. So you've got to do another evaporation test, right? Just to check and be totally sure that everything that you think you got out, you really did truly get out. Because if you see that the number stays the same after the second trial, you know that everything's good to go. You're A-okay. You've evaporated absolutely everything. And there's your answer for the second conclusion question, or third. I've lost count at this point. I'm driving a manual car, so it's quite difficult. So what are some sources of error in this experiment? Well, something that I thought might have an impact is, what if we don't dry the crucible fully before we put stuff in it? That could be really bad, because then we've got more than we think we do. We mass it, and we'd be getting the mass of the crucible plus the water that we haven't managed to fully dry out yet, which is really bad. So we've got to fully dry out the crucible before we start messing around with massing anything. So that's one source of error. So finally, how could the water be put back into the salt? Well, this one is also very simple as well. All you got to do is dissolve the salt in some water, because it is a salt. It will dissolve when you put it in water, and then you just got to let all the excess water evaporate. Because think about it, when Mr. Wickrant had the salt up there, the water was trapped inside of the salt. It wasn't escaping because it was evaporating as he spoke. So as we let it dissolve, all the hydrates will come back and take their place back in the salt. And as we let all the excess evaporate, that'll get rid of anything else. So we'll be left with, once it's all evaporated, our solid strontium chloride salt that we had before. So there's your answer to the final conclusion question, and we are D-U-N done. And I can focus on driving now. Love you.